Good afternoon. Welcome at the review session. A little bit different time, but I see the attendance is excellent. Excellent, excellent. That's maybe this works. Maybe we can have that time, but we will see for this week and probably next 2 weeks, we will have the Tuesday session at 3 p.m. Okay. I hope we can accommodate more students. Yeah. And if you didn't have a chance to attend live session, you can try, maybe. We'll see. Hello. Thank you for using the chat box. Okay, let's start. Review session for midterm 1, because this week is the midterm 1 week 4. We will have today's session, and you will also have the second part tomorrow. We will try to review today integration, yes, the entire chapter 7, including 7.7 improper integrals. And tomorrow you will review differential equations, yeah, the 2 sections from chapter 9, and indeterminate forms 4.5, yeah, which you enjoyed the last week. Okay, the test now, yes, important information. The midterm 1, exam midterm 1 will be open Friday, and it will stay available until Monday, June 12th. Of course, 11:59 p.m. Eastern Standard Time. That's it. Please plan accordingly. The test, you will probably need around a little bit less than 2 hours to take the test. That means please do not wait until the last minute. If you open your test, if you start your test, let's say 10 minutes before midnight, which I do not recommend doing this, you will only have 10 minutes because at midnight on Monday, it will be locked. Right? But yeah, nobody will wait until this. But saying that the test is open, it's available, it is available for a couple of days. That means you may take wherever, whenever you, whatever time works for you. You can pick a day, a time, and you can take your test. The test you will take on Canvas, but it will go through the HonorLog platform, the proctoring platform. Most of the students took the practice quiz for the HonorLog. If you still didn't take it, I will recommend taking before the midterm, just checking if you are ready, if you satisfy all of the requirements, like camera, microphone, internet. You can take it, just 3 questions, but you can check if you're ready technically. Okay, that's all of the technical question, because it will be really sad if you will email me Monday 5 minutes before midnight that you have some problems. No, don't create this scenario for yourself. No, because that's not good. Try to take it earlier than Monday. I mean, you can still take it Monday, but be ready. Yes, know what to expect, because you can do it. And now the material. That's mean we know the day, we know the technical things. Okay. That's another information. We're taking this test without any additional help. Yes, no calculators, no notes, no electronic equipment devices, no searching the website. Basically, just you and the pencil and the scrap paper. You may have a scrap paper to solve the problem, because how we can solve the problems without the paper. Okay? And you will have around 100, maybe a little bit more, because you have to situate. But yeah, let's say 100 minutes to complete all questions. They will be multiple choice or maybe drop down menu, but no open-ended question, no writing solutions and scanning and posting. No, everything will be the selection on the screen. And that means please be really careful, because multiple choice questions, if we know what we're doing, they are extremely helpful. But if we're trying to guess, most likely we will guess wrong. That means please only do the educated guess, or maybe avoid the guessing. Solve the problem and find, yes, the correct answer based on your solution. How many questions submit? Oh no, I just said no partial credit. I mean, no open-ended question, no writing will be submitted. No. It is basically the same format like weekly quizzes on Canvas. And this is also one of my recommendations. You may go through the past 3 weeks and check the weekly quizzes, because the questions, the type of the questions will be similar. Okay. Yes, weekly quizzes, and definitely going through all of the practice problems that I prepared for you. You know, I know that you know they are placed in week 4, the module 4 on Canvas, and please try to solve all of them. Okay? All of them, and you will be well prepared. That means you may go through quizzes, practice problems, all of the practice problems, and you will also take a practice test, which is for extra credit. Will also give you the taste of the actual exam, and then after doing all of these 3 steps, you will take your actual test. Do not reverse the order. Do not reverse. I mean, oh, no, don't worry for number of questions. I don't want to answer how many questions. The test is worth 100 points. Yes, 100 points. That means ideal will be to give you 20 questions, each worth 5 points. But sometimes the questions are slightly longer, sometimes are a little bit shorter, then the number can change. But it's around 20. Okay, but if it's 22, please do not complain. Okay, no, it's around 20 problems. Okay, around 20 problems, but plus or minus, let's say plus or minus 5. I will give myself, the margin. Yes, the practice test is for extra credit. You know everything. You know everything. Everything is on Canvas. Okay, that means this, let me check some other questions. Okay, that means this is the material, the entire chapter 7, 9.1, 9.2, and 4.5. I think I include 7.7 in chapter 7, that's because this was the last week. But 7.7. And the yellow, this 5.7, 5.8, that's the old material. Pre-calc 1. Pre-calc 2, that's calc 1. That means we know just the U substitution. Okay, that means let's attack chapter 7. Okay? And if you have any integral, any question, you may ask me, I can, yes. But it will still be on the exam. Yes. What on the exam? I don't know, Zander, the old. I mean, in order to finalize, for instance, integration by parts or trigonometric integrals. Yes, we will always think about the previous. Yeah, that means it could be not directly. We could not create the direct question from 5.7, 5.8, but it's always hidden here. Yes, it's like mathematics. When we learn one concept in elementary school, we can't throw the concept in the middle school or high school or college level. Yeah, it's always it's like a brick. That's when we still have to know. But even maybe the direct question, but most likely not directly asking, which I think I have a couple of integrals. Right away, we can apply U substitution. Okay, that's we can see not bad. And I really recommend going through all of the beautiful list of the review problems that I prepared for you, and it's sitting in week 4, module for week 4. Okay. And what I just have a selection of integrals. Let's go through, let's solve it. Also, you may try not to skip any question on my presentation. Yeah, it will be also helpful. If you follow everything, you will ace it. Okay, I don't know if that's proper English. Okay. We recognize that list. It's a formula. That's, let's see, we're starting our review. Let's see. Even if I skip some questions, I will provide for you, as always, this presentation with my solution will be added with my writing. That's the direct formulas, direct antiderivatives. We know all of them, which, however, maybe number 4 looks like a U substitution, and number 7, it's not a number, but number 7 is a U substitution for number 6. Number 4 is the U substitution for number 1. And the rest of them is just direct antiderivatives. And I know that I asked you a couple of times, number 11, do we know integral of tangent of x? Or if you don't know, do you know how to solve it? What method you will apply? Yeah, you can help me. You know that I always ask questions because I like my students to be active. You may do this way. Yes, Nick. Or, and you will do the U substitution, and the final answer is supposed to be natural log of secant of x, or natural log of cosine of x, but negative. Oh, constant C. Yes, also, it's also, yes, perfect. Because the negative in front of the logarithm can be placed as an exponent, cosine to the negative 1, reciprocal of cosine is secant. Okay, but if you don't remember, do that, put that form and use the U, apply the U substitution. Okay, now let's see what I have. We remember this, we will go through each section, 7.1. Integration by parts, we know the formula, we know everything. This is the typical examples. I latte, I late, whatever we can read this, it's a little bit helpful to choose the function which will represent U. Whichever letter is first on that, each letter represents the function, the following functions. It's easier to use as a U instead of dv, because we remember U and dv, we have to make the decision from the integrand. Okay, so for instance, what I have. I thought that I have integral. Okay, that's me. Let's see, 7.2. Really quickly, you may pause the video later, yes, and think about this. 7.2, we also remember no reduction formulas, no crazy things. 7.2, I will really recommend that you will treat this as a Calc 1, Calc 1 section, because it's direct antiderivatives. We know this one. Maybe sine square of x and cosine square of x, who can remind us? It's also the formula from pre-calc, but maybe that was the information that we will use. What we will use? We will use the half angle formula. 1 minus cosine of the double x over 2, yes, and 1 plus also cosine. Yeah, half, yes, thank you. Oh yes, you even know and then everybody can integrate because the square is gone, the multiplication is gone. I think please remember, use the half angle if the degree is even. And now we did a little bit of this, sine of x times cosine of x, or tangent of x times secant of x. Depends on the powers. If both of them are even, we will use half angle for sine and cosine. If it's like both odd or even and odd, we will just use the U substitution. One of the way will work. Tangent and secant, the same thing. If I don't want to say this, I think I have this one. That's what I'm trying to say, but I don't want to make any big theory. It's just the U substitution. If we think about derivatives, if one exponent is odd, one even, or both odd, then we will try. You can try. Sometimes both of them will work, sometimes only one substitution, but this is the only two options. You could be sine of x or you could be cosine of x. And we know the Pythagorean identity. Yes, we know how to rewrite, okay, one function in terms of the other. Let me check this. Tangent, yeah, the same thing. If both are even, yeah, then we will do tangent because of the derivative. Yes, the derivative is secant square. And then if both are odd exponent, I'm talking about these exponents, then we will do secant because derivative, we can see no even powers. And also we have to know Pythagorean identity. Let me, 1 second, I will just, okay. Okay, that's we remember this. And then what I have now, 7.3 trigonometric substitution. Yeah? We also cover this. We have 3 typicals like expression that if you see them, you may think, oh, trig substitution will work. And that's the expression. Yeah? Most likely it will be square root expression, square root. Please pay attention to the quantity inside. Yes? Like a constant minus x squared, constant plus x squared, and x squared minus a constant. Everything, it's and then the substitution, it's like must correspond. I mean, it is the result of the identity because we can see constant, which we can factor out that constant, making the x, replacing x with a, which will be square root of that constant. Yes, we can see if that constant is 4, then we will do the substitution 2 sine theta. If that constant is, for instance, 9, we will do 3 sine theta. Because we will square, you can see x is squared, and we will have that, let's say 9 minus 9 sine square. And that 9 will be factored out, and under the square root, we will only have 1 minus sine square theta. Okay, and how we can rewrite 1 minus sine square theta? Cosine square theta. And if we think that this is under the square root, can we simplify square root of cosine square? We still have to be careful because when we have expressions squared under the square root, this is the correct simplification. But if we know that x is positive, if this quantity is positive, we can skip, we don't have to put absolute value. And we know, yes, for all of this, this will work. Cosine theta or secant theta or tangent theta, it is positive because we do have a certain domain restriction since we're involving inverse of all of this. And for the inverse trigonometric functions, in order to have them, we did restrict the domain of the periodic function, one-to-one function and other properties. Okay, just a little bit of theory. But please, yes, please always know what you're looking for, and you see occasionally, even if we don't see the square root, but you still see this subtraction or addition, this expression, you may still try u sub. You can still, I mean trigonometric substitution. You can still try this substitution, right? Because even if we don't have this square root, it will help. Okay? Okay. Because we can see from the expanded form, we're actually making one item, one function, and that's helpful for the integration. Okay, 7.3, now 7.5, integration by partial fraction decomposition, case 1, 2, and 3. We remember all of the denominators, the factors are linear, none of them is repeated. Case 2, all of them, the linear factors, but some of them are identical. Case 3, some of them are quadratic, irreducible. And let's make sure that we know how to get the partial fractions. You know. Okay, and this was the summary, 7.6, all of them. We, of course, know, yes, know algebra system. No, I saw on the discussion that somebody was like recommending some reduction formulas. No. Oh no, the reduction formulas actually are for this. Trigonometric identities and the no. We know that's the reduction. We not, no. Basic. This is 7.2, basic U substitution and just thinking. Okay, and then 7.7 is improper integrals, but we will do at the end. Okay, let's maybe solve 1 or 2 each. We will be. So what I have, let's see. You will not miss any integral. You can even do it with me now, because I will ask you a question. Oh, okay. Let's start with this. Actually, yeah, good integrals. Let's say this is A and this is B. Did I have the, oh, I don't have it. Okay, we will try to squeeze it. We have some information and then we have some, the integral from 0 to 5 equals to 7, f of x dx, some information about f of x for a couple of points, and the information for derivative of the function f at 0, 5, 10, and 20. Okay, calculate the integral from 0 to 10, f prime of 2x times e to the power of f of 2x. Okay, what method you will use? I like the table questions. Okay, U sub. Yes, that's it. Let's do the U sub. And what? It's actually the U substitution. Really good. Yes, just the inner function. Because this is the inner function, e to the power of a function. And it's always, that's supposed to be our first guess. Du will be 2 times f prime of 2x dx. We know this. And then this is just 1/2 du, and f prime of 2x dx. F prime of 2x dx is sitting and waiting to be cancelled out. I can maybe rewrite f of 2x times f prime of 2x dx. Okay, and this is from 0 to 10. E to the power of u, and that expression we can see f prime of 2x dx is 1/2 du. Okay, 1/2 e to the u du, integral of e to the u, And what we can do, yes, we can actually find the new limits of integration. Because we have a definite integral with the u substitution. Okay, that's new limits. When x was 0, then u will be f of 2 times 0, which is 0. What is f of 0? And when x was 10, f of 2 times 10, we can see 2, 20. What is f of 0? F of 0 is 1, thank you, we can see this. And f of 20? 18, thank you, that's new, good. Yeah, we did similar, I remember something. Okay, 1/2 e to the 18 minus e, done. Okay, and we can leave it like this, possibly factor out e. Okay, that means this is part A. How we can approach part B? X squared times the second derivative. What do you think? Integration, please be before me, yes. I always want my students to be faster than me. I'm too slow. Thank you. Okay, let's start. U, du, dv, and v. The top line, u and dv, we have to pick from integrand, x squared and the derivative. Yes, of course, we will do x squared and we will do second derivative. Derivative of x squared is 2x dx. And what about antiderivative? Yes, it will be just f prime of x, because derivative of f prime, it's f double prime. Perfect. And do you remember I was using the blue pen in my UV VDU. Maybe I can write here. UV minus integral of VDU. That's the formula. Everybody knows this. Okay, x squared f prime of x, and then minus integral of 2x f prime of x. Oh no, do we have to do it again? Because we have x times f prime of x. Oh, I don't know if I like this. Okay, let's do it. U du, I will put 2x, and dv will be the derivative. Yes, I'm just doing this one and this one. And then v is just a function. This is just constant too. Perfect. Now we have to be careful. Okay, I can use green. UV VDU. UV minus integral VDU. The only thing that we have to remember, we have negative in front. Okay, so let's see. X squared f prime of x minus, and this will be 2x f of x UV minus integral of 2 times f of x dx. Okay. And everything, we're not changing any limits of integration, yes? Because we didn't really use substitution. I don't have enough room. Maybe I can add a slide really quickly. Do you have the answer? What's the final answer for this? Okay, that's when we will have x squared. Oh, wait a minute, f prime. F prime. Now, minus 2 x f of x, and then negative and am I actually right? Yes. 2, okay. Yes, 2, correct, plus. Plus 2 integral of f of x dx. Everything is from 0 to 5. From 0 to 5. Okay, that's when we can substitute, yes, using the fundamental theorem of calculus. But what about this integral from 0 to 5? What we can do with this? Oh, the second integral is not there. Oh, let's wait. Oh, that's not an integral. That was f of x. Deepen. I don't know if you... This was 2x times f of x minus 2 times integral of f of x. Yeah, I think it's correct. But what my question is, we have not enough information. Okay, we have not enough information to compute this, but this is given. If you look at this integral is 7. Okay, that means sometimes, yeah, look for this, 2 times 7. This is 7. Okay, but we do have that means let's really quickly substitute. You may watch me. I will substitute 5. It will be 25, f prime at 5, minus 10, f of 5. Oh, actually, and then I have to substitute 0, but 0 will give me 0. Yes, because this is 0 and this is 0. That means we have just 0. Okay. This will be plus 14, but we need the value f prime at 5. F prime. What is f prime at 5? Who can give me the value first? Yes. F prime at 5 is 2. 2. And we need f at 5. F at 5 is 6. Yes. Nihal, you really fast. And now 50 minus 60 plus 14. 4? No. 4. Please check. Because my arithmetic must be, we know that, yeah, okay. Okay, that's it. Thank you for confirming. I always need another, yes, I see the thumbs up. I need a couple of eyes to, actually all of your eyes. Okay, nice integral, really nice, yeah? Couple of things, but really nice. And probably you can do faster. I was just talking. Okay, that's mean limit. I mean, not limit, oh, I was thinking about improper. Table kind of the integrals. Okay, now something like this. Do we know what to do? Maybe I can leave it. Please just tell me and I can add the solution later and you can try. What you will do? We know tangent. Yes, I will just be careful with that. That's mean, let's do the U substitution. And this will give us extra coefficient 1/3. Yes. I mean, this will be 1/3 tangent of U. And we know the integral natural log of secant of U. And we just need a new limits of integration. Yes, but we have this extra 1/3. If x is 0, 3 times 0 is 0, that's the new one. And pi over 12, 3 times pi over 12, pi over 4. Oh, nice, yeah. Nice values for secant. Yes, and you can do it. Substitute the upper, substitute the lower limit. Okay, now, this one, what you will do? Inverse sine of x over square root of 1 minus x squared. Also the U substitution, because it's like sitting and waiting. Derivative of this is placed in the integrand. I mean, we don't even have to, yes, that part, can I write here? That part is basically du. It means it's just U du. U squared over 2. And what about the limits of integration? 0, and then sine for what angle is 1/2? Pi over 6. Pi over 6. Yeah, I saw pi over, okay, let's wait. Because 0, and this will be pi over 6. Yes, it is the last option. Yes, we have to memorize. Yeah, I mean, just the basic, yes, just the basic trigonometric like values for the reference. I mean, for the special angles, 0, 30, 45, 60. 45. Okay, yes, let's keep working. Am I sharing? Okay, let's wait. No, something is okay. Yes, yeah, I think I hit something. Okay, this one easy. What substitution? Again, the U substitution. Actually, I think I said it will be no direct ln of x, and then you can do it. I will leave it for you. Okay, this one is ln of x over x. What about this one? Ln of x, natural, yes, over x squared. Yeah, that means it's extra x, and that extra x will not let us really like nicely use the U sub and simplify. That means this will be integration by parts. Let's do it. U, du, dv, and dv. Okay, what is U, what is dv? Yes, this will be ln of x, okay, and yes, because this is my main question. We do not like have function x squared. we have x to the negative 2, because integration by parts, we always have to identify a product of two functions, and then we're using. So please remember not x squared in this, just x to the negative. And then this is derivative. What's the antiderivative? Negative 1 over x. Please check if I am right. Yes, okay, good. And then we will have, where is pen? uv v du, uv integral v du. I hope on the test you will just hear my voice. uv integral v du. Okay, negative natural log of x over x, and then integral of actually plus. Do you agree? Please watch me, and this is the final answer. Yeah. You have to really watch me what I'm doing. I'm asking questions, but yeah, sometimes a little bit faster. But this was the main thing, x to the negative 2. Yeah? Okay, now next. Okay, this one is nice integral, simple but nice. You can do it. Maybe I can leave it, but please tell me what you will do. Too many nice integrals from Calc 1. I think we can try this. As the only, I hope you remember, like when we getting du equals to dx, I'm always a little bit worried, because this might indicate that we're not changing anything. We're just rewriting in terms of a new variable. But this one will work because we will make just one quantity in the denominator. Yes, that means we will make, let me write a little bit lower, because we will have square root of u, du is dx, that means I can put du, but what about x? What about x? I can't really put x. Yes, we have to figure out what is x in terms of u, and this will be u minus 1. If I take this substitution and solve for x, u minus 1. And then we can split. Yes. Yeah, you can keep that free, or you can factor out. I mean, we will have u over square root of u and 1 over square root of u. Okay, and this is 1 minus 1/2, it's 1/2. This one is negative half. And now everybody can use the power rule. Just the new limits. Please tell me, what are the new limits of integration? New bounds. When x was 0, 0 plus 1, 1. When x was, yes, 3, 3 plus 1, 4. I mean from 1 to 4, from 1 to 4, not from 0 to 3. Okay, you can finish this. You can check later. You will. Yes, I know that you will. Okay, too easy. Yes, yes, thank you for helping me. Good, I like the participation. And I love some of your, like most of your discussion, like posts. Yeah, sometimes they are like, I'm not even writing feedback, which I'm just giving you full credit, but they are beautiful. You contributing really nicely. And if you're getting 4 points because I'm grading this means that I love your contribution to the class, because what I want from this discussion, put like as helpful information as you can for others. Yeah, this is like kind of giving moment, giving away moment. Yeah, please do not treat the discussion assignments as like, oh, I have to get my points. No, don't do this. Try to contribute. Okay, most of you are doing perfectly. Okay. Is answer A for this one? I don't know. I don't know, maybe because I don't see, I have my solution somewhere, but I don't see the answer. Good, if you Sahil. Oh, you can message the whole class instead of, but yeah. Okay, what method we will use? Arctangent of x, because that's my main point. I think will be integration by parts. We will make the second part 1. Who answered Nihal? I think you messed up, you mixed, not messed up. Messed up is too much to say. You thinking about this. Am I right? You thinking about this integral, not about the other way. Arctangent of x dx. We don't know. Yes, we have to find a function, question mark. That question mark, when we differentiate, we will get arctangent of x. Yeah? Okay, yes, yeah. Which is still good if we remember this one. Yeah, we will definitely do, oh, wait a minute. Oh, okay, you're just writing the other way. We have to put arctangent of x because we know the derivative, and we will put 1 dx because we know the antiderivative is actually x. And this one will be, we actually need this. Okay, and the magic formula, UV, VDU, let me write here, UV integral of VDU, and let me put just my screen, I can write here, x arc tangent of x minus integral of x 1 plus x squared dx. Okay. What about that integral? X over 1 plus x squared, quantity 1 plus x squared. What you will do? We will use the u substitution, and we will let denominator, yes? Because since we have on the top the variable, it will be not arctangent. If with a constant on the top, yes, but not this one. We will let u to be denominator, and then we will have 2x, 1/2 ln of u, which u was the denominator. Or we actually have a limits of integration. Oh, no, limits of integration. We're not changing, we didn't change from 0 to 1. Okay, I did skip the u substitution, but I did use the u substitution in my head. Okay, and I think, yes, looks like answer 1. Let's see, 1 arc tan of 1 minus 1/2 ln of 1 plus 1, 2. And then 0, actually 0 will be 0, right? Arc tan of 0, 1/2 ln of 1. ln of 1 is 0. That means this is 0. Arctangent of 1. Tangent for what angle is 1? Tangent for what angle is 1? I know. I have so many smart students. I really like it. Yes, that's the correct answer. A, S. But please be careful with the multiple choice. Okay. Okay. All right. Let's actually x secant square of x. Nice integral. Product by parts. Integration by parts. I can leave it. You can make the selection, okay, later. Check my writing later. Okay. Sine square of x and cosine square of x. I will recommend to know that, because you can see integral like this one, or you can see as a result for the trig substitution. Do we know what formula we will use? 1 minus cosine of 2x over 2. 1/2 integral of 1 dx is x. Integral of cosine 2x is sine of 2x over 2. Okay? I think you can find the option. Which option is good? D? No, not D, not D, because we need extra, I think the last one. E, thank you. Because 2 times 2 will give us 4 in the denominator. Okay, we good with this one? Sine squared times cosine cube. What substitution we can make? I will really, yes, recommend to going through section 7.2, and I think I solved, yeah, nice integrals. This is typical. We have odd exponent, odd power, cosine cube. Maybe we can, yes, we will keep sine square, we will keep cosine square, and we will keep single cosine. And this will be reserved for the du. If this is du derivative, we need everything in terms of sine. Yes, in terms of sine. I mean, this is good. How we can rewrite cosine square in terms of sine? Oh, let me just. Okay. Somebody is bothering me. 1 minus, yes, 1 minus sine square theta, cosine theta, d theta. Okay, and now, yes, u is sine theta, and du is in the box. Cosine theta, d theta. Very nice integral. 3u squared, 1 minus u squared, and this is du. Well, it's really nice. We may distribute 3u squared, 3u to the power of 4. And now everybody knows how to integrate the power function. Please just tell me new limits of integration. New limits? If theta is 0, what is sine of 0? If theta is 0, u will be sine of 0. If theta is pi over 2, u is sine of pi over 2. This is 0, this is 1. 0, 1, 0, 1. Okay, you can, yes, you can do it. Okay, now from 0 to 1. Yes, tangent, secant, the same thing. We have actually secant, I mean tangent cube and secant to the power of 7, both odd. Yep, probably we know what to do. Let's pull out for like one single. We can leave it tangent square and we can leave it secant to the power of 6, and then secant and tangent can be left at the end. Derivative of what function is in the box? Derivative of secant tangent of secant. Thank you. That's we want u to be secant. Yes, I'm kind of like changing the order. That means this is good because this will be u to the power of 6. How can I rewrite tangent square in terms of secant? That's important. I want my students to know this. This is my du. Tangent square is secant square theta minus 1. Okay. U squared minus 1, u to the power of 6, and this is du. Yes, u to the power of 8 when we distribute, u to the power of 6, du. And what are the limits of integration? Oh, we don't have a limits. Oh, just the indefinite integral. U to the power of 9 over 9, U to the power of 7 over 7, and U was secant theta, because we have to get back to the original variable. It is answer A or C? Oh, somebody said C. I think it's A. Yes, 9 and 7A. Okay, thank you for confirming. Because we will rewrite in terms of secant. Okay, we done 7.2. Nice integration, yes? Okay. Oh, this is nice. It's not typical trig integral from 7.2, but we can also use the same method. Yes, we will use tangent. We will use tangent because what's the derivative of tangent? Secant square and secant square of x dx. That means this is du. And how we can rewrite secant square in terms of tangent? Because the boxed formula must stay, because this will be du. I can start backwards. Secant square x dx, then u is tangent. Secant square is 1 plus tangent square. Thank you. Okay, 1 plus u squared, square root of u, and u. And we know we can rewrite as two fractions. Okay, and power function, u to the negative half, u to the power of 3/2. And you can finish. The first two steps are important. Okay, good. You will not miss this one. Oh, that's square root. Maybe you know the answer right away, but maybe not. Maybe not. Oh, okay, maybe not. Let's see. That's what we see here. We see the square root expression, right? And we have a constant minus x squared. What trigonometric substitution will be good? Trigonometric. X, yes, that coefficient, that constant 3 will force us to have a coefficient 3. I mean constant 9 will force us to have a coefficient 3, and this is sine. We remember that table. Please look at that table that I provide for you for section 7.3. And then dx is derivative cosine theta d theta. Okay. Let me write. Can I write? Hey, 1, 9 minus, and this will be squared, 9 sine squared theta. And dx, it's 3 cosine theta d theta. Okay, that's what we can do. I can maybe put 3 cosine theta d theta. Denominator, how we can simplify the denominator? Can I maybe write the denominator? We know the purpose of that 3 because it's 9. We may factor out. Correct. This is still square root of 9 and square root of this. What is 1 minus sine square theta? It's cosine square theta. This is 3. How we can simplify square root and the squared quantity? They cancel out, but we allowed to do this because of the domain. We don't have to keep absolute value, because normally it's absolute value, but cosine is actually positive for the restriction of the inverse sine. Okay, that means this is 3 cosine theta. Oh, wow, we can cancel out everything. It's just 1. What's the integral of 1 d theta? Just theta. Yes, but hang on, yes, I did everything correct. But now theta, we have to rewrite theta in terms of x. X was 3 sine theta. Then sine theta is x over 3. Then theta is inverse sine. Yeah, we're just reversing the, okay. So the final answer is inverse sine of x over 3 plus the constant. No extra coefficient. That means I will definitely do this integral this way. I will not guess. Yeah, I think option A is a little bit tricky. Yeah, but we do not have any extra coefficient. Okay. So we know this. We know that integration. Let's see. Oh, that will be. Let me check what I have. This one. Okay, shall we do this? Let's do it. And let's maybe do 1 or 2 integration by, yeah, we will finish. I'm just worried that as I said, if we not finish, you good with integration. Okay. Oh, but is this the same type? What technique you will use for this integral? X squared over 49 minus x squared. Please tell me, I think we will not do it because we just did similar. But please tell me what substitution. It will be still sine, but 7. Huh? 7 sine theta. And you can, okay, I will leave it this one for you. Let's maybe do this one then. 1 over x squared and then square root of the quantity x squared plus 1. What trig substitution? Because it's positive, yeah, the second line in that table. Tangent. When both positive, it will be tangent. Yes, tangent, thank you. Dx is derivative of tangent, secant square theta d theta. Let's see what we will get. Oh, no. Okay. I mean, dx is secant square theta d theta. X squared is tangent square theta, and x is tangent square theta plus 1. Oh, we have d theta on the top. Okay, secant square theta, tangent square theta, I can put d theta. How we can simplify the square root? Square root of tan square theta plus 1. This is secant square theta. Correct? And then we can rewrite as a secant. Okay, I will rewrite for you. This is just secant theta after simplifying. Then we have 1 secant on the top and tangent square theta. Okay, we did the trig substitution. We end up with the trigonometric integral. That's typical. What do you suggest? I personally will rewrite in terms of sine and cosine. Yes, or maybe secant. Yeah, I will rewrite in terms of sine and cosine. Secant is 1 over cosine, and tangent is tangent square, sine square over cosine square. Am I right? Then we will have 1 cosine and sine square. Okay, makes sense. Oh, actually, we can do the u substitution. Or what about this one? It's a direct. Okay, I will write this. 1 over sine is cosecant. Cosine over sine is cotangent. I switch the order. Do we know the formula for this? Cosecant times cotangent. That's the direct antiderivative. Negative cosecant theta. Because derivative of cosecant theta is negative cosecant cotangent. Am I right? Please check. You can still do the u substitution for that line. Yeah, let u to be sine. And you can also get this one. Okay, negative cosecant theta. Do you agree or yes? Because I need your confirmation. Perfect. The only step that we have to do it, which actually it's my point, we have to rewrite in terms of x. Okay, that's mean we have to know what is cosecant theta in terms of x. What we know tangent theta is just x. Or maybe even better, x over 1, the ratio. And we will use this tool, triangle method, as a help. Okay. Who can tell me the ratio for tangent theta in the triangle, like adjacent, hypotenuse, opposite, x over 1? What's the ratio for tangent? I know the session is long. What's the ratio for tangent? Opposite over adjacent, really good. That's mean x looks like an opposite and 1, yes, x over 1. 1 is adjacent. If this is x, this is 1, Pythagorean theorem will tell us that this is x squared plus 1 square root. And I don't know if we remember, but probably when you watch my session for the trig substitution, when we using this method and computing the third side, because always the third one will be missing, that square root is always the same as we saw in the original form of this integral. Yeah, you can see x squared plus 1, x squared plus 1. If it's something wrong, something different in the triangle, we may think, okay, we probably make some mistake. This root expression must be the same. Just a little bit of pattern. Okay, when we have each side, we may say what is cosecant. Please tell me, what's the ratio for cosecant? Reciprocal of sine. Is this one, hypotenuse over opposite? Please confirm that I am right. I'm just writing backwards. X squared plus 1. This is hypotenuse over opposite. Okay, this is the final answer. Yes, I was going backwards. Okay, triangle method. And remember what kind of substitution. Okay, so now 7.5. This one, it's the rational function. How many partial fractions you will create? We even have 2. Okay, I can leave it this one for you because by now you're probably perfectly fine with this. Okay, what about this one? How many partial fractions you will create? I can write the fraction 3. And now 1, 2, 3. Okay, I would like you to tell me the denominators and then I can leave it. It will be A, B, and C, of course, because each of them is linear. Okay, one of the denominator will be x plus 5. One of them will be x plus 5 squared. And one of them will be this one. Okay, that means you're ready. You're practicing. You're working every day a little bit, right? Because we remember, we cannot get ready to take the part of the, like to run the marathon and get ready, like trying to get ready in like 2 or 3 nights before. Decomposition though. You still confused. Do you have like a specific question? how do you split up the numerator? Could you please do? What do you mean numerator? Numerator, we comparing. Let me check. Okay, we can do this one. Okay, we can do the next one, but we not now. I have the basic understanding, but also it's, if you have a basic understanding, you struggle. That's the normal learning curve. But okay, this one we can see, we know we can integrate, yes? We can integrate each of this part. A natural log of x plus 5 minus b over x plus 5, and then c natural log plus the constant c. And then in order to find coefficient a, b, and c, we will use the algebra. Yeah. I can possibly write this equation, but I will leave it this one for you. That's and we will solve the next one as a last integral, okay? 36, that's the numerator. Now, when we look at these three fractions, partial fractions, and thinking that we would like to combine again, creating the common denominator, which will be identical like on the left-hand side, then the numerator will be in the form of these coefficients, a, b, and c. Okay, that means now let's see, a. Yeah, the quantity a has underneath x plus 5. Then in order to create this common denominator, just one extra x plus 5 is missing. Yes, I will multiply this and x minus 1, because one of them x plus 5 is there. Okay, now b. Underneath b, we have x plus 5 squared. That means we good with this one. We're just missing x minus 1. Yeah, for the common denominator. Now, c has x minus 1. That means has this one, doesn't have the component of x plus 5 squared. Yeah, that means I hope we can. And now we have a couple of ways to get coefficients, but yeah, let's maybe do the first method. When we substitute 1 instead of x, what we getting? 36, this is gone, this is gone. 5 plus 1, 6, 6 squared is 36c, c is 1. Really nice. Now I can substitute -5. Oh. And what we getting? This is still 36, gone, gone, -6b. b is 6. Oh no, b is -6. b is -6, correct? Do you know what values of x I pick? Why I pick 1 and -5? Because they are zeros. But for this case, this is case 2, we have more coefficient to find than the zeros, because they are repeated. -5 is repeated twice. We can see this squared. Then I still missing a. We can pick up any other values. Yeah, let's create, like, let's take 0, because that's one of the easy. We will have this 0, 0, -5a, 0, -b, 0, 25c, correct? But now we can substitute, of course. I can substitute this. Then we will actually, let me write higher. Okay. 36, -5a, this will be +6, and this will be +25. And now we can solve for a. 5a equals to 31 minus 36. Also -1? I mean, also negative, I was thinking. But please check if I am right. -5 divided by 5, -1. Okay? And then we can just substitute. This will be negative. And then negative and negative positive. 5 and then 1 natural log. This is plus 5. Perfect. Yeah? Okay, that means this is case 2. Let's do case 3 and we will finish. Yeah? Because in proper integrals, we know how we will just apply all of the rules of integration. I mean, whichever works, but remember the limits. At the end, we have two limits. And I have 2 integrals. I will solve for them, but try to solve before me. Okay? But to finalize this session, let's do this integral. Okay? And we're done. I know if you really have to go, you may go. If not, let's still, stay. Okay, what you will do for this integral? What's the first step? Okay, let's solve beautifully this integral we have. We have 3x squared minus 2x plus 8. It's definitely proper. It's definitely proper and proper rational function. And we remember, we always start like trying to factor out denominator. That's when we do have 2 factors, x and x squared plus 4. Quadratic irreducible. We cannot factor further. So in how many partial fractions we will have? Whichever factors, like whatever number of factors we have. Yes, 2. That's when we will have x and x squared plus 4. Because x squared plus 4 we cannot simplify. Oh, I see, yes. And now, constant above the linear, but this is quadratic irreducible. We will put linear term, bx plus c, okay? Or mx plus b, whichever labels, whichever letters you like. Okay, that means this one, let's actually find a, b, and c, and then integrate. Okay, numerator, 3x squared minus 2x plus 8. It has to be the same like the numerator on the right-hand side when we will try to combine these partial fractions again together. Okay, that means common denominator is, of course, a product of these 2. Then a will be multiplied by x squared plus 4 only because x is there. And bx plus c will be multiplied by x. That's actually easy. I mean, I did the same in the previous one, but was free. I know everybody understands this. Okay, and this one, since how many zeros we have of the denominator in this example? How many x value will give us 0 in the denominator? Just 1, yes. Yes, I was, Nihal, yes. The answer, I mean, to confirm your statement, your question, the answer is yes. And thank you for answering, yes. We have only 1. And how many coefficients we have to find out? Yeah, like the letters that we see on the screen. A, B, and C, yes. That means the other method will be a little bit like maybe too complicated. Let's look at the different method. I will distribute ax squared, a times 4, bx squared plus cx. And we can see we have ax squared and bx squared. When I factor out x squared, looks like this. We have cx and we have 4a. Now, these 2 sides, left and the right-hand side, they have to be identical, meaning that the coefficient of x squared must be the same. That means a plus b equals to 3. Now, coefficient of x must be the same as this one. C is -2. We can see how nice and easy. And the constant must be the same like this one. Okay, 4a equals to 8. Beautiful. Then please tell me A, B, and C. C is -2. Yes, yes, perfect. Yes, really nice. Theoretically, you can do it for every case 1, 2, and 3. But for the case 3, with the quadratic irreducible denominator, this is the best method. Yeah? It's fast. Otherwise, we will have a system of 2 equations, another system, too complicated, yes? Yes, A is 2, and Xander, B is 1. I think B is 1. Thank you. Beautiful. So nice. And I also want to thank you, like, if you're presenting your written homework this way, it's also like really nice, really nice. Okay, 2 over x plus x minus 2, x squared plus 4. Okay, and I will suggest the second fraction to split for 2 fractions. X over x squared plus 4 minus a constant 2 over x squared plus 4. That's mean, again, another like suggestion for the irreducible denominator. Yeah, let's do this one because we know what denominators suggest, arctangent. And only arctangent if it's a constant. That means that x, bx, x, x. Yeah, it's different. Okay, this integral is 2 ln of x. This one, use substitution, yeah, but I think we will have 1/2 ln of x squared because 2x, 1/2, okay. And what about this integral? I can maybe copy the integral. Okay. What is this integral? Who can tell me? It's x squared plus 4. If this will be x squared plus 1, we know it will be just arctangent of x. But this one is arctangent, and that 4 affects the x that we will divide by 2, and also we will divide by 2 entire function. Yeah, it's actually 1/2. Yes, not 2, depends at 2. It will be 1/2 of arctangent of x/2. But 1/2 times 2, it's cancelled out, but it's still part of the expression, which is, this one. Okay, I can just nicely copy for my students. Okay, perfect. It's really nice integral. All of them are really nice. Yeah. Okay, that means let's finish. I will give it to you like maybe in 1 hour. I can clean it, I can add the missing solutions. And where does the 1/2 come from? It's actually the formula. Let me maybe write. I mean, you can still use the U substitution. If it's x squared plus 1, this one is arctangent of x. Yeah. Okay, but when we have integral x squared plus a squared, it's still arctangent, but x is affected by a, and also the entire arctangent is affected. We will divide by a, x, and the entire function. So now, if that quantity, if this quantity is 9, then we will divide by 3. If this quantity is 81, we will divide by 9. If this quantity is 4, please tell me what will be the denominators? 2. Yes, Nick, that's the 1/2 that you're asking. Okay? Yes, and I can let me maybe leave it the general. If it's a squared, it will be a and a. Yes, that's mean that we had 4, we have 1/2. Okay, that means please double check the integrals that I may be missed. I will add the solution, you can solve it. And one more time, please check all of the practice like the review problems that I provided for you in the module, in the exam one module. Okay, if you will go through all of the questions, you have the solutions, check the solution. I know that I might do the typo. I think, Deepan, thank you for finding my typos. I believe I correct them. I didn't distribute the negative a couple of times. Yes, thank you for telling me. If you find any typo, that's also a good learning process. Tell me right away. I'm saying for this review because I was like solving them, and I hope it's no more typos, but if you see something, you can tell me. Okay, please enjoy the next review session tomorrow. Double check this presentation. And yes, I wish you all the best for the exam one. Yeah, do not mess up. Don't mess up. Okay? I believe in you. I have so many excellent students. Okay, thank you. And yeah, you will see me next week at 3 p.m. We will cover a new stuff. Interesting class. Join me. Thank you.